Okay, hi everyone and welcome back for lesson 2 of module 1. So as I mentioned in the last lesson, the first number corresponds to the module, the second number here after the dot corresponds to the lesson. So this corresponds to your eCampus page as well. So today we're going to be talking about solving linear equations and inequalities. Our essential question is, what properties can you use to solve equations and inequalities? And our goal will be to solve equations and inequalities using the properties of equality and inequality. So let's talk about two terms that we use in math, solving and evaluating. Often used interchangeably, but technically they do have specific definitions. So when you're solving something, you're finding the value that makes an equation or inequality true. This is when you're solving something like this here, where you have an equal sign. Okay, when you have an equal sign, that means you're going to be solving for the variable. You're going to find the value for the variable which makes the equation true, or the inequality true. When you evaluate, this is when you're dealing with an expression. So an expression is a mathematical sentence, essentially, without an equal sign. And it's often represented with variables, sometimes not with variables, sometimes it's just numbers. And we're going to simplify by sometimes we're plugging in or substituting in for the variable, and we're going to evaluate and find a value. So that's when we don't have an equal sign. And then a literal equation is an equation containing more than one variable. So oftentimes when you're dealing with a literal equation, you're going to be asked to go ahead and solve for a certain variable. And it's going to look like an equation. So 3 common math errors. So this is pretty straightforward. This is just talking about some errors that are common that students make that you want to look out for. So sometimes you're rushing and you write down the problem incorrectly. Of course, if you're trying to solve a problem that's different than the actual problem, your answer is not going to be correct. Signs, so oftentimes students will overlook a plus or a minus or see it as the opposite. So always check and make sure your signs are correct. And then just incorrectly calculating the computation. So just be aware and checking your work. It's important to check your work in math. A lot of times you can actually check your work to verify that it's correct, so you want to take advantage of that. So you solve equations. You evaluate expressions. And you always include the variable as part of your answer to an equation or inequality. You're always saying like x equals 3. X is greater than 3. That would be a solution to an equation or an inequality. So here we're just going to solve a 2-step equation. So you should all have done this before, but we'll refresh your memory on that. So we have that minus 4. We're trying to solve for the variable to get the variable by itself, so we're going to get everything else to the opposite side. And by doing that, we're going to do opposite operations. So we know that in math, addition reverses subtraction. So I'm going to add forward to both sides. This is called the addition or additive property of equality. So we're going to cancel out here, and we're left with 2x is equal to 10. We're going to use the division property of equality, and we're left with x equals 5. Now that would be the solution to my equation. Now if you plug this or substitute the x back in to the expression on the left, that should give you the answer that you have on the right, and that's how you can check your work to show that it's true. Now over here we're dealing with an absolute value. Now remember that an absolute value is one's distance from 0. So let's go ahead and plug in and evaluate. So we have the absolute value of 2 times negative 4 minus 3 times 3, absolute value bar, equal to, now I'm going to solve inside the absolute value bar because remember, we talked yesterday, or the last lesson whenever you had it with me, we talked about this being a form of grouping, so we're going to work with inside that grouping. Now I'm going to do the multiplication first because multiplication comes before subtraction, so that's going to give me negative 8 minus 9. Now I'm evaluating inside the grouping, so that's the absolute value of negative 17. So that means that negative 17's distance from 0 is 17. So to kind of refresh your memory on that, if you haven't done it in a while, if you have a number line and you have 0 in the middle of that number line, and then over here on the left you have negative 17, and over here on the right you have regular positive 17. Now, of course, I just drew this, a sketch, so it's not going to be exact, but the distance, in theory, from negative 17 to 0 and 0 to positive 17, this distance is the same. So that's what an absolute value represents. So I just want to refresh your memory on that. And now we'll go ahead and move on to the next page. So here we have what's called the literal equation, because the definition of a literal equation is an equation that contains more than one variable. And of course here we have 3 variables. So we're asked to solve for g, which means that we want to get everything that isn't g on this right side over to the left side to isolate g. So I see that g is being multiplied by 1/2 and also being multiplied by t squared. So another way that we can write something being multiplied by 1/2, it's the same thing as being divided by 2. So I'm going to write it as being divided by 2. Now I know in math when I want to reverse division, I can do multiplication. So I multiply by 2 on both sides. That cancels out my 2 on my right. That leaves me with 2s is equal to g times t squared. Of course, these are products, so I want to get rid of the t squared, so I'm going to divide t squared on both sides. That leaves me with 2s over t squared is equal to g. So I don't really like using s as a variable because it kind of looks like a 5, but it's not. So that would be the answer. So this one says solve and graph, and this is an inequality. Negative 2x plus 4 is greater than 20. So I'm going to rewrite it down here so we have room. Now the first thing I'm going to do is I'm going to get rid of this positive 4 because I want to get x by itself. So I'm going to subtract 4 from both sides. That leaves me with negative 2x is greater than 16. Now I'm going to go ahead and divide both sides by the negative 2. Now I don't know if you remember this or not, but when you do divide or multiply by a negative across an inequality, you need to flip the inequality. So I'm going to flip my inequality because I'm dividing or multiplying by a negative. That's going to give me negative 8. So we know that x is less than negative 8. So we want to plot that on our number line. So typically if you're just asked to sketch a number line, go ahead and start with the middle number being the one that is in the inequality you just solved. So negative 8, and then I'm going to do one that's smaller than it and one that's bigger than it. And then we have to determine if it's an open or closed circle when we plot the inequality. So open circle is when you have a greater than or less than that does not have an equal sign underneath it. So we have an open circle here because there's no equal sign underneath the inequality. Then we have to determine what direction our arrow is going to go. So we know that x is less than, not included, but less than negative 8. So that means we're going to be going in this direction. So that would be how you plot your inequality. Now you can always check your work by plugging in a value, say less than negative 8, to see if it works. So I know that negative 10 is less than negative 8. So let's go ahead and plug that in. Now if I plug in negative 10, negative 2 times negative 10 is 20. So 20 plus 4 is 24. 24 is definitely greater than 20. So you can also check something that wouldn't fit in the inequality and check your work that way as well. So like I said, it's always a good idea to test your work and ensure that you've done it correctly. Now here, we're just going to talk about solving equations and inequalities and what our goal is. So our goal is always to isolate the variable. And there's an approach, it's an acronym, it's called SCAMIT. So the acronym stands for simplifying each side using order of operations, which we talked about in the previous lesson. The next one is going to be combine like terms and collect variables on one side. Our next goal will be to add or subtract using the inverse operation to undo, which we've done multiple times in the examples, and then to multiply or divide using inverse operation to undo. So, of course, addition reverses multiplication. and vice versa. So addition reverses oh my gosh, did I say multiplication? No. Addition reverses subtraction, and subtraction reverses addition. Multiplication reverses division, and division reverses multiplication. So just keep that in mind. If you end up with one or more solutions, these are known as roots. So roots is one of the many words used for solutions. You'll see zeros, roots, answers, solutions, but we're going to talk about it in the terms of the word root. And then if we get a true statement such as 0 equals 0, when we solve, that means that we have infinitely many solutions. A false statement, if we end up with in an inequality or equation, say we end up with something like 1 equals 2, that would mean that we have no solution. So yeah, I don't know why my computer notifies me of stuff on Google. I can't get rid of it. I don't know why, so just ignore that. It's like news or something. So now let's go ahead and solve this equation. So we're going to have to be doing a lot of simplifying on both sides here. So over here I have parentheses, grouping. There's nothing to do inside the grouping, but I can use the distributive property because we have addition and subtraction here, and distributive property is a form of multiplication, so we know that comes before addition or subtraction. So I'm going to distribute. That leaves me with negative 10x plus 12x minus 6 is equal to, I'm going to distribute over here as well. That gives me 8x minus 12. Now I'm going to combine like terms on my left. That gives me 2x minus 6 is equal to 8x minus 12. Now you have multiple options here. I'm going to go with what's easiest for me. I'm going to subtract 2x on both sides. That leaves me with negative 6 is equal to 6x minus 12. Now I'm going to add 12 to both sides. That leaves me with 6 is equal to 6x. Divide both sides by 6, and that gives me x equals 1. Like I said, you can verify this by plugging x back into the equation and ensuring that both sides are equal to each other. Now over here, once again, I'm going to use the distributive property. That gives me 5x minus 20 equals 3x plus 2x minus 20. Combine like terms. Let's add 20 to both sides. We're left with 5x is equal to 5x. Well, divide by. So x equals x is a true statement, right? So if we look back to our rules, a true statement such as, or a true statement equal to 0, 0, well, you could say this case it is equal to 0, 0 because it is a true statement. That means that we have infinitely many solutions. So continuing on, we have a few more examples here. I'm going to use the distributive property. That's 2x minus 2 plus 3, just bringing down the 3 here, is equal to 3x. Now I'm going to distribute that negative. Remember, you have to distribute the negative when you have parentheses like that. That's like multiplying by a negative 1. So everything's going to change signs inside the parentheses due to that minus. Now I'm going to combine like terms on each side. So on this side that leaves me with plus 1, and over here that leaves me with 2x minus 4. I'm just bringing this down so I have room to do the work. Now I'm going to add 4 to both sides. That leaves me with 2x plus 5 is equal to 2x. I subtract 2x on both sides, and I'm left with 5 is equal to 0. Now this is not a true statement, which means that there are no, I believe the terminology is real, but I don't think we said that. Yeah, no solutions. We'll just go with that. We're not going to get too in depth. So no solutions. So now we're going to do an inequality. So once again, we're going to use the distributive property here. That leaves me with 3x plus 6 plus 1 is less than or equal to 5x minus 9. Combine like terms. I'm just going to bring it down here to finish. I hate trying to scrunch it in because I want you to be able to see what's going on. I'm going to subtract the 5x on both sides. Like I said, there are sometimes multiple ways to do this correctly. That's going to leave me with negative 2x plus 7 is less than or equal to negative 9. I'm going to subtract 7 on both sides. That leaves me with negative 2x is less than or equal to, this would be negative 16. Yeah. Now I'm going to divide both sides by negative 2. Remember, when you divide or multiply by a negative over an inequality, your inequality sign is going to flip, and that leaves me with x is greater than or equal to 8. So we're going to plot it on the number line. So we have 8. Pick a number lower and a number higher. Then we have our circle. Now this time our circle is filled in, and it's filled in because we have an equal sign under the inequality. What that means is that 8 is included. So x is greater than or equal to 8, which means 8 is included in the solution set here. So 8 is an included value. So we know that it's going to be greater than, which means we're going to go to the greater direction. And theoretically what that means is a number of 8 or greater will satisfy this inequality, and you can check that on your own. So that's it for this lesson. If you have any questions, feel free to reach out to me, and all of the methods and ways to do that are outlined for you on your eCampus page. So have a great rest of your day.